They work by introducing a mixture of detergent and water into your clothes to absorb dirt from them. However, having clothes soaked in soapy water is not sufficient to get rid of all those pesky stains. They also need to be thrashed around a little to ensure that the detergent water mixture reaches every spot and so that the clothes rub against one another to get the stains out. That's why washing machines have two systems which work together in tandem to allow the clothes to be washed. A plumbing system controlling the water in and out of the machine, and a mechanical system to control the rotation of the drum, allowing the clothes to be tumbled around. This is all monitored by a computer system which keeps everything in sync. To start with, the user fills the detergent and fabric softener tray. There are usually 3 sections in the tray. The section marked number 1 is for the pre-wash, number 2 is for the main wash. This is the main one we use, and the last one is for the fabric softener. Then the user selects the desired type of wash from the values available, such as delicates, synthetics, quick wash and heavy loads. Each of these all have a corresponding temperature, wash time and spin speed. The variation between the types of wash is because of the many different types of fibers that make up our clothing today. They all have optimal washing conditions to balance the prevention of damage with rigorous washing. Water enters into the machine via a water inlet. In the past, machines had 2 inlets, one for hot and one for cold, but now the majority have one cold inlet and an internal heating system for increased efficiency and control. There is also a thermostat within the drum which monitors the temperature and communicates it with the computer to make sure that the water stays within the desired range. You don't want the water to get too hot as your clothes may no longer fit. The water from the inlet then passes through into the detergent tray, absorbing whatever is inside to create a soapy mixture. After that, the water flows through a valve into a watertight drum ready to clean the clothes. So how do detergents absorb dirt? They can do this because they are a type of surfactant. They have one side that is attracted to water, referred to as hydrophilic, and another side which is not attracted to water, called hydrophobic. This side is instead attracted to oil, dirt and grease. So when the detergent meets the dirt in your clothes, the surfactants surround it, enclosing it within a sphere. When the water flows over the clothes, it carries the detergent and the dirt along with it, because the hydrophilic side likes to stick with the water. This means the greasy stains are carried away from the clothes. One side note is that using too much detergent can be harmful to the machine, as it can build up in nooks and crannies inside the piping. This becomes a breeding ground for mold and bacteria, leaving white marks and a pongy odour on your clothes. Within the watertight drum there is another drum which has holes all over and is capable of rotating. This is where your clothes are actually placed. A motor is needed to spin this drum, sometimes directly on the drum, or it can be connected via a belt system. However, it's not just simple one-way rotation, as during the washing phase the drum rotates in one direction then the other to ensure maximum agitation in the load. Depending on the user inputs, the computer can cause the motor to spin faster for heavy loads or slower for more delicate items. The drum also has several fins around the circumference to act as agitators so that the clothes don't clump together when spinning, allowing every surface of clothing to be exposed to soap and to rub against one another to get rid of those persistent stains. The rotating drum is the main area of difference between top-load and front-load washers. In top-load washers, it's an agitator in the middle that spins rather than the drum itself. The agitators are screw-shaped, causing the clothes to be lifted up and tumbled around. The main benefit to top-load washers are that they are simpler, easier to use as there's no bending when loading and unloading, and that they have a lower initial cost. However, they use more water as the full drum needs to be filled. They also are louder and less energy efficient, meaning the lifetime costs can be higher. Surrounding the drum, there are springs, dampers and weights to prevent excessive vibrations caused by the spinning load. If you overload the washing machine, these springs, the motor and the tub bearings can become overstressed, potentially damaging the appliance. Once the cycle is complete, the computer opens the outlet valve so the dirty detergent water mix can be pumped out. This passes through a filter to catch any debris like jewellery. This prevents damage to sensitive components such as the pump. It's also a saviour for people like me who always forget to check their pockets before washing. A common problem is when the washing machine is either draining slowly or not draining at all is a blocked filter. These should be cleaned out every few months and they are usually accessible at the front of the machine. The cycle of pumping clean water in, mixing with detergent, spinning and pumping out again is repeated several times during the cycle chosen. At the end, the clothes are spun at a higher speed to squeeze out as much water as possible. Now, all that's left to do is dry. Washing clothes in the past was an arduous process, requiring lots of precious water, especially if you weren't lucky enough to live close to a source of water. Basic soaps invented by Romans and commercialized by the Arabs made things a little easier due to the surfactant qualities that we discussed earlier, but it still required a lot of hard work. Water would be boiled in huge pots, mixed with precious soap and the clothes soaked and beaten with a paddle, starting with the cleanest and finishing with the dirtiest to prevent water waste. Later on, planks of wood with grooves called washboards were developed, which aided scrubbing, saving time. An American called James King revolutionized clothes washing with his device patented in 1851. It featured a hand-cranked agitator in a barrel. An optional clothes wringer was added later to squeeze out the water. These machines were mainly used in a commercial setting, but this is where William Blackstone saw an opportunity. He created a cheaper domestic version mainly to ease his wife's workload. The first electric machine came in 1908 with a machine called Thor. Improvements to washers came in the 1950s, allowing for variation in the settings based on the type of clothing. By the 1990s, computer chips were added to improve timing. Have washing machines reached their final form, or will there be more additions to their design? Let's see what the future holds. I've started committing a lot more time to these videos and hopefully you guys are seeing the impact. I know there's a few mistakes here and there, but I'm learning as I go along. I'd really appreciate it if you guys could check out some of my other videos and subscribe if you like what you're seeing.